Number 1, my x-intercept, I don't know why I started with x, but whatever, none. My y-intercept, none. I guess it doesn't matter which one I start with, right? My y-intercept is going to be 0, 1/4. X-intercept, 4, 0. Okay. Y-intercept, 0, 0. X-intercept, 0, 0, of course. And 4, 0, and -4, 0. And then y-intercept is 0, -1/2, and x-intercept is 1, 0. Which one, Conrad? Okay.
Half of the cube root of 1 is just 1.
Yeah, cubed root of 1 is 1.
Right. Except 3, I have no idea how to do 3.
Oh.
Probably just made that.
You didn't know how to do number 3?
No, I didn't know how to simplify the bottom.
You didn't have to simplify the bottom. But how do you simplify?
Because I couldn't, so I didn't know.
Well, you factor out a 4, right?
I know.
And I get x squared minus x minus 6. And then you can go.
Yeah, it's 6, yeah. I just did the math wrong.
So it doesn't simplify to anything.
Oh, I got x squared minus x minus 5. I was like, that does not.
No, that doesn't work.
So I just moved on.
Oh, you did. Oh, okay.
4, not 3.
Okay. Yeah, so that's it. Okay, so now we're going to graph. Yay. So exciting. Okay. So I kind of made some steps for graphing. You don't have to follow them, but this is how I do it when I'm thinking about graphing. So step 1, factor and simplify. It's the first thing you do, right? Step 2, find any holes. Holes appear when the same factor in both the numerator and denominator. I just wrote down the directions in case you guys need them. So holes appear when I simplify and I cross out, right? When I make a 1 with x's. Find the vertical asymptotes at the denominator equals 0, solve for x. Find the x-intercepts, find the y-intercepts, find the horizontal or slant asymptotes. And then place all the above information on the graph. That's what we're going to do first. And then we fill in our curves. Okay? So we're going to do all that stuff. And you don't have to do it in that order. That's just the order that I kind of think about in, and I probably won't do them all in that order. I'm just going to tell you. They'll probably go just bounce around in whatever order. It just happens to be the easiest to do it in. Okay? So here we go. So we got our first graph. So I'm going to factor it first, right? So is that big enough for you guys to see in here? Sure, thanks. See, if I make it big enough for you to see, only half the graph is on the iPad, so that's why I have to ask you guys. So I have 1 over, what is that? X plus 3 times x minus 2. Yeah, that looks good. So holes, and I'm just going to run down it. There should be none. Vertical asymptotes. I should have one at x equals -3 and x equals 2. Great. Horizontal asymptotes. Well, let's see. The top is smaller than the bottom, so that is y equals 0, I believe. Well, since you're not going to need to, because you have your notes with you when you have to take the checkpoints or whatever, you'll have this with you, right? It's on the front page. The top is smaller than the bottom, so it's y equals 0. Step 6. Okay. And then the x-intercept is where, let's see, x-intercept is where I set y equal to 0. So it's where the numerator is equal to 0. So there is no x-intercepts. Y-intercept. is where the x is 0, so that's negative 1/6. And then my domain, let's see, negative infinity to -3, -3 to 2, 2 to infinity. Beautiful. Okay, because there's no holes. In domain, I just use the holes in the vertical asymptotes to find the domain. Those are where the domain doesn't exist. Now I'm going to put all that information onto my graph. Asymptotes go on as a dotted line. Okay, holes go on as a hole, right? You just draw a hole. And then we're going to see what we get. So we have a vertical asymptote at x equals -3. And we have one at 2. And we have a horizontal asymptote at 0. That's a little harder to see, that one. And then we have a y-intercept at 0, -1/6, so somewhere in there. Okay. So now the problem becomes, I have 6 parts of my graph. Where's everything else going to be at? Right? So all I'm going to do is I'm going to pick a number in one of those areas and just plug it in and see where that's going to be at, if it's going to be up or down. So if I'm going to just pick some values, So if I just make a quick table, x and y, right? If I pick, say, negative, I'm just going to try and pick easy ones. So I'm going to pick -4, and I'm just going to plug -4 in. So I've got 1 over -4 plus 3 times -4 minus 2. Boy, that's so readable. So 1 over -1 times -6. So that's positive 1/6. So that means in this area, it's on top of this graph. So it's going to look like this. Beautiful. And then I'm going to do, let's do positive 3. I'm going to be willing to bet it's going to be in the same area. So 1 over 3 plus 3 times 3 minus 2, which is going to be 1 over 6 times 1. I almost said 9. Yes, I know. 1/6. So it is again 3. I'm at 1/6. So again, it looks like this. Curve down. That should be a curve and not a square. Sorry. My drawings are not. It's just that, by the way, it says sketch, so it doesn't have to be exact. Okay, so we're sketching it. And since my y-intercept, I already know where my y-intercept is. Where is it? It's below the axis. So this one's going to kind of go up. And there's no x-intercept, so I know it doesn't cross the x-axis. I should have did this graph in a different color. Sorry. So I know there's no x, so it doesn't cross the x-axis. So it should look like this. Now, we can check ourselves. And how can we do that? I can take, this equation, and I'm going to stop sharing this screen for a second. And I'm going to pull this over here because you guys need to see it too. So I have Desmos out, right? So share screen, share Desmos graphing calculator. And if I just put in the equation here, which is, I guess I need this up here. 1 divided by, I'm going to put this in parentheses, so x squared plus x minus 6. It should look like what we graphed. Pretty dang close, right? To what we sketched, anyways. So that's, there you go. The problem with Desmos, I'm going to tell you, you can kind of tell where the asymptotes are. It does not put any holes in holes in there, so it will not show any holes. It will not show the asymptotes as a dotted line. It will not show those things on Desmos. But you can get an idea of what the graph is supposed to look like. So the important thing is that we know where those main things are, and we get those plotted on the graph, and then we just sketch the rest of them. As you see, it didn't take very long just to plug in 2 values to find out where my graph is going to be. Okay? So that's what it looks like. Beautiful. Okay, so let me put that down. We might come back to that. Here we go. So let's do another one. You ready? Yeah? Okay, we got pretty much the same denominator. For the first couple problems, we got the same denominator. We're just going to see what happens to the numerator as we change, happens to the graph as we change the numerator and keep the denominator the same. So if I factor that, right, so it's x plus 1 over x plus 3 times x minus 2, okay? So, again, no holes, none. Vertical asymptotes, again, same place, x equals -3 and x equals 2. What's next? Sorry, horizontal asymptotes is y equals 0 again, so that didn't change. X-intercept is where 0, or y equals 0. So I set the top equal to 0, and I get -1. So now I have a x-intercept. My y-intercept is 0, still the same, -1, 6. Domain should be the same, -infinity to -3, -3 to 2, 2 to infinity. There we go. Okay, any questions about how we found anything? Sorry, I don't have the question thing up. The chat box, the question thing. Wow, okay. So let's plot them. -3. 2. -1, 6. Oh, 0. Sorry, I don't know why I said -1, 6. 0. And then I have a x-intercept at -1, 0. And -1, 6 is my x-intercept. So again, I need to test out my a couple spots. Pretty sure the middle, x, y. We'll talk about the middle in just a second. Again, I'm going to plug in -4 and see if it made that big of a change or if I'm still in the positive. So I have a positive side and I have a negative side. I just want to know if it's going to be above the x-axis or below the x-axis, really. That's really all I need to know, because if it's above the x-axis, then it's going to be in this area up here. If it's negative, then it'll be in this area down here, because I don't really need to know the point since I'm just sketching it. If I had to graph it and be exact with it, then I might have to know where some more points are, but we don't have to. We just have to sketch. So I've got -4 plus 1 over -4 plus 3 times -4 minus 2. I want to talk about that for a minute for you guys, especially those of you who are going into calculus. When I was talking about if I just need to know if it's positive or negative, it's called making a sign line. And I only need to know what the sign is. I don't care what the value is. I just need to know if my answer is going to be positive or negative. So I could figure out that really easy. I could say, Let me do this really quick. So -4 plus 1 is a negative, right? It's going to give me a negative value. -4 minus 3 also gives me a negative value, times a negative value. What's that going to be overall, positive or negative? Negative. So this is going to be negative, which means this one is going to be down here this time. I don't need to know what the value is. I don't care what the value is. I just need to know what area my sketch is going to be in. Does that make sense? So it's called making a sign line, and all I need to know is what the sign is. Don't care what the value is. And you're going to do that a lot. If you take calculus, you'll do that a lot when you're dealing with graphs, is just finding the sign line. Okay? So I can do the same thing if I'm with 3, right? 3 plus 1 gives me a positive number. And then 3 plus 3 gives me a positive number. And 3 minus 2 gives me a positive number. Oh, that gives me a positive number. So that means it should be up here. Whew. Okay. And then, so I kind of need to know what's happening in the middle. I'm pretty sure that this part from my x-intercept to my y-intercept is going to kind of go like this. But then I need to know from -1 to -3 what's going to happen. Is it going to come back down or is it going to go up? I think it's going to go up. But I'm just going to plug in -2 and I'm going to do another quick sign line. It doesn't take very long to do that sign line, right? It's pretty easy. It's faster than actually finding the value. So -2 plus 1 is a negative. Yeah, I'm running out of room. I'll write it here. -2 plus 3 is a positive over a negative. So that is a positive. So that means it's going to go up into this area. And I should have done it in a different color. Sorry. So now my graph has this funky little shape to it. Just all by changing and putting an X in my numerator changes my graph that much. Okay? Not too bad? Not too bad? Or bad?
Good.
Good? Yeah. Okay. I think I have 2 more examples to do before I let you guys do some and try it on your own. Is that okay? Okay. So again, we have the same denominator. So I think this is the last one with the same denominator though. So I have x plus 3 over x plus 3 times x minus 2. So that goes away and my equation becomes 1 over x minus 2. Okay? So holes. Do I have a hole? And where's it located at? -3, right? And then -3, let's see, and -1/5. Yeah. And then I have a vertical asymptote at x equals 2, a horizontal asymptote again at y equals 0, a x-intercept at, let's see, -1/2, 0, a y-intercept at, oh, I think I did that one wrong. Sorry. I think I was thinking y-intercept, 0, -1/2. So no x-intercept, none. There we go. Okay, and then domain would be -infinity to -3. Look, my domain happens to be the same, 2 and 2 to infinity. So the domain is the same. The only thing that changed is now I have a hole and 1 vertical asymptote. Okay. So here we go. You guys ready to graph? Okay. So I'm going to put in my asymptotes first. So I've got one at 2. Beautiful. And I've got one at 0. And then I have a hole at -3, -1/5. And when we say hole, I know it takes up more space than it's supposed to, but it's a hole. There's a hole there. Draw a hole. See? Hole. Okay? And then I have a y-intercept at 0, -0.5. And no x-intercepts. Oh, well, this one's going to be easy peasy. Okay, so I'm pretty sure that this bottom one is going to look like this. I don't even need to take an example of this one. It's going to look like this one. And then I'm pretty sure, we're just going to do a quick sign line, but I'm pretty sure this top one is going to be in the upper corner. But if I plug in,
I think she's pretty sure of that.
huh? Just from seeing tons of these graphs. Usually, if it only has one x, it's in opposite corners like this. Just.
So we're finding that you use the simplified.
I use the simplified one, yeah, because it's easier. So if I plug in 3, I've got a positive number over a positive number is a positive number. So there you go. Right, 1 is positive, and then 3 minus 2 is positive. So there we go. Beautiful. And honestly, to draw the hole, you just go to the hole, stop, pick up on the other side, and that's how you draw a hole in your graph. Graphing calculators do not do that. They don't put holes in your graphs. So if you have a hole in your graph and you go off your graphing calculator and then you don't put it on there, it will be wrong. Okay, so you need to make sure you calculate that and be careful with your asymptotes. Okay, so let's see. One more. Whew. I don't know about this one. We're going to try it. It's as simplified as it's going to go, right? Doesn't simplify anymore. So holes, there are none. Vertical asymptotes, there are none. There are, but they're imaginary, so there really are none. Right? Okay. Horizontal asymptote, y equals 0. X-intercept, x-intercept was where I take the top and set it equal to 0. So that would be 0, 0. Y-intercept is going to be 0, 0. Domain, is that next? Yep. Domain, -infinity to infinity. Because there's no holes and no vertical asymptote. So everything can be in there. So I still don't have any idea what this graph looks like, right? Because is there any information for me? I know there's a little bit. There's a y-intercept. And there's this. Yeah, it gives me absolutely no information on this graph. So what am I going to do? Plug it into Desmos. Yeah. I'm going to plug it into Desmos. If I can find Desmos. There it is. Okay, so Desmos. Oh, it helps if you actually push share, huh? Okay, so I think it says x divided by x squared plus 1? Yeah. Plus 1. And there we go.
What is that?
That is the graph of this function.
I've never seen it.
So it looks like there's a point at 1, -1. Oh, no, that's -1.5. -1.5 and 1.5. And then it's approaching Oh, let's do it in a different color here. It's approaching my asymptotes, and it kind of goes down a little bit and up a little bit and back down. And that's what it looks like. Oh, you guys can't see my graph.
Is this stuff gonna be on test then, like we're gonna graph it?
This, yeah. Okay. It was probably, the graphing's more like probably matching matching graphs. Yeah, I speak good English. I'm just going to do these really quick and write down the answers, and then if you guys have questions, let me know. X-intercept is 0, 0. Y-intercept is 0, 0. It looks like a check on the end instead of an arrow. Let's see. I've got a 0, 0, and I think that's all the points I have. Okay, there's the first one. Second one, factors 2. Vertical asymptote, x equals -4. Horizontal asymptote, y equals 1. X-intercept, none. Y-intercept, 0, -1. Domain, -infinity and -4. -4 to 1. 1 to infinity. Okay, so -4. 1. Have a hole at 4, 0, a y-intercept at 0, -1. So this one's going to look like this. And then this one's up here in the positive area. Boom, there you go. Except it crossed the asymptote a little bit, sorry. So what you got, Lucy?
I just did the graphing part wrong.
Okay. Plug it into Desmos. She wants to do it on her own, Conrad.
Desmos wants to do it on its own.
Oh, did I mess that up? Let me go back and look, sorry. It should be 4. It should be 4 instead of 1. +4 and -4. I'm so sorry, John. It's the whole and the vertical asymptote, 4 and -4. Thank you. Thank you for catching me. Thank you very much. But it's not a blast. You caught me doing something wrong. Thank you. I'm thanking you. Okay, let's see, factor, right? So I've got x minus 5 times x plus 3 all over x minus 5. So that gives me x plus 3. So I have a hole at 5, 8. Vertical asymptotes, none. Horizontal asymptote, none. X-intercept, -3, 0. Y-intercept, 0, 3. Domain, -infinity to 5, and 5 to infinity. So at 5, 8, I've got a hole. And 3, 0, -3, 0. Done. Does the domain go through the hole? No, sorry. Why does the domain go to 1? Are you talking about the last problem? Sorry. I'm sorry I missed your question. I just thank you for that. Oh my. Okay. D. Factor x over, factor out an x, x minus 4. The x's go away, and I get 1 over x minus 4. So I have a hole at 0. Sorry, not 0. Yes, 0. Why did I put my hole there? What did I do? Interesting. Oh, I'm on the wrong problem. No wonder. Okay, I'm like, what did I do? Okay, -1/4. Okay, there we go. Vertical asymptote, x equals 4. Horizontal asymptote, y equals 0. X-intercept, none. Y-intercept, 0, -1/4. So basically I don't have a y-intercept either. My domain is going to be from -infinity to 0. Oh, and I have a vertical asymptote, 0 to 4, and 4 to infinity. Oh, I messed that one up too. Okay. So vertical asymptote at 4. Good. And a horizontal asymptote at 0. Okay. And I have a hole at 0, -1/4. 0, -1/4. So right there. And no x-intercept, no nothing else. So this one is going to look here. And then when I plugged in, I don't know what I plugged in 5, I got a positive, so it's going to stay up here. So that's what this one looks like. And then the last one is an interesting looking graph. So I factored the top again. X minus 5, x plus 3 all over x squared. So there's no holes. Vertical asymptotes, x equals 0. Horizontal asymptotes, y equals 1. X-intercept, set the y numerator equal to 0. So I've got 5, 0, and -3, 0. Y-intercept, none. Domain is from -infinity to 0 and 0 to infinity. So let's see. There's that. And then I've got one at 1. And 5, 0, I've got a x-intercept, -3, 0, I've got an x-intercept. So this one looked like this. And like this. And that's what this graph looked like. Weird. But there you go. Any questions? Lovely. So you have 10 problems on Delta Math to prepare for Thursday. Thursday.
Is there anything tomorrow?
No. Just study for Thursday.
Nice.
I know, right? Make sure you have all your missing work done, if you have any. A lot of you don't have any, by the way, but some of you do. So get your missing work done.